now. So here we will discuss the history of engine types. So we'll uh, discuss the history of internal combustion engine. So here internal we'll click this link. So it's not highlighted here. So here I will highlight. So just so in 1972 it's not showing. So I will click again. So the signal is very weak. It's not opening it. So now it's opening. So it's not highlighted. Okay. So here it's coming. So in 18, this is pertaining to the history of internal combustion engine. So in 1872, American George Brighton invented the first commercial liquid fuel internal combustion engine. So in 1876, Nicholas Otto, working with Gottlieb Daimler and Wilhelm Maybach, patented the compressed charge four-stroke cycle engine. In 1879, Carl Benz patented a reliable two-stroke gas engine. So that is a history of internal combustion engine. So we have here also in 1892, Rudolf Diesel developed the first compressed charge a compression ignition engine. So in 1926, Robert Goddard launched the first liquid fueled rocket. In 1939, the Hinkel E178 became the world's. So this is a aircraft now. Hinkel E178 became the world's first jet aircraft. So in 1954, German engineer Felix Wankel patented a pistonless engine using an eccentric rotary design. So those are the history of internal combustion engine. So we'll proceed to the next. happened to this? You are disturbing. So now, let us proceed to the learning outcome number 2. Differentiate internal combustion engine and external combustion engine. So, I will click this link. So here, so in this lesson, you will learn what an external combustion engine and how it differs from internal combustion engine. So you also learn about the different types of external combustion engines and what they are used for. The external combustion engine, meaning external combustion engine uses a working fluid, either a liquid or gas or both, that is heated by a fuel burned outside the engine. So external means outside. The external combustion chamber is filled with a fuel and air mixture that is ignited to produce a large amount of heat. This heat is then used to heat the internal working fluid, either through the engine wall or heat exchanger. The fluid expands when heated, acting on the mechanism of the engine, thus producing motion and usable work. So we will differentiate the two types of engine, which is external and internal. So external versus internal combustion engine. So the difference between the external and internal combustion engines, it is quite straightforward and is made obvious by the difference in their names. So by the names itself, external and internal, they are already different. So in an external combustion engine, the fuel isn't burned. So this is the keyword. Remember this. So this is a keyword. So in the external combustion engine, the fuel isn't burned inside the engine itself. So with the internal combustion engine, the combustion chamber lies right on the middle of the engine. So later on, we will see the example of the external combustion engine. External engines have a working fluid that is heated by the fuel. So here it comes. Internal combustion engines rely on the explosive power of the fuel with the engine to produce work. Internal combustion engines, the explosion forcefully pushes piston to expel high pressure gas out of the engine at a great speeds. Both moving piston and ejected high speed gas have the ability to do work. In external combustion engines, combustion heats fluids which turns all the work, which in turn does all the work. So here, we will give an example, external combustion engine. So one example is steam engine. So here we come. So later on, you can see the picture, huh? So steam engine is one type of external combustion engine. So in a steam engine, a fuel such as coal burned in the combustion chamber. The heat turns water in a boiler to steam. So if you remember the movie Titanic, so it is a true story. So if you remember, the fuel used that time is coal. So they use coal fuel in the boiler. So nowadays, so I will excuse me, I will so nowadays the fuel of the boiler is, so I will check here if there is a pin. So it is this pin. So I cannot see where is the pin. So here, review. So here is the pin. So I can write now. So during the times of the Titanic, the fuel of the boiler there in the ship Titanic is coal. So nowadays, the fuel of the boiler is this one is black, no? So I have to change into red. Thickness. So the fuel nowadays is MDO, marine diesel oil, MGO, marine gas oil, HFO, heavy fuel oil, LFO, light fuel oil, IFO, intermediate fuel oil. So that is the fuel. So these are the fuel being used on the boiler nowadays. So before it was coal. So during the time of Titanic, so it was coal. So why this is steam engine is called external combustion engine. So this steam engine, one example here is steam turbine. So I cannot write outside. So steam turbine. So that is one example of steam engine nowadays. So another. So I will erase this one. Will erase. So the fuel is born in the boiler here to generate steam, and the steam is used to steam engine, to drive the steam engine. So that is one example of steam engine. So next we have here the Stirling engine. So another example of external combustion engine. is Stirling engine. Stirling engine differs from the steam engine in that its working fluid always, so I will erase this one, always in the gaseous phase. So as opposed to the steam engine, which turns the liquid water into gaseous steam, furthermore, the Stirling engine continuously recycles its working fluid, whereas steam engine dump into the condensed steam once it's been through the engine. So here, later on, we can see the so I have to erase first. So later we can see the diagram later. So as we go on with our discussion, so I will close this window. So here we already differentiate the internal combustion engine and the external combustion engine. So we will describe the different classification of internal combustion engine. So I will click this link. So it's not opening. Once again. So it's quite hard to open the link if the signal is not good. So here we will talk the classification of engine. So here our example here is engine design and classification, how automotive engines are categorized. So in this automotive engine, this is also similar to the marine engine, the principle, but the difference, for example, such as cooling, is different because here in the automotive engine, it is a combination, the cooling system is a combination of the coolant, the cooling water, fresh water, and the air, so through radiator. But in the ship, there is a freshwater cooler, and the fresh water is being cooled by seawater, and the engine is being cooled by the fresh water. So now here. So engine design and classification. So we have here, we can classify the engine, generally classified according to the following different categories. So we have number one, internal combustion internal combustion, which is IC, and external combustion, which is EC. So number 2 category, type of fuel. So in internal combustion engine and external combustion engine, they are using petrol or gasoline, using diesel fuel, gas fuel, and biofuel. So number 3, number of strokes. So internal combustion engine also is classified by number of stroke, 2-stroke. So there is 2-stroke petrol engine, 2-stroke diesel engine, 4-stroke petrol engine, and 4-stroke diesel engine. So number 4, they are also classified as the type of ignition, such as spark ignition and compression ignition. So they are also classified as the number of cylinder. So from 1 up to 18 cylinder. So it depends on the design. Arrangement of cylinder, which are inline and V-type. So there are also W type and horizontal type and radial type. So it depends on the design. So the motion of pistons is either rotary or reciprocating. So they are also categorized as naturally aspirated, turbocharged, or supercharged. So that is these are the classification of engine, and this is categorized according to this information. So since we have here the spark ignition and combustion ignition, so SI engine and CI engine. So here we will talk about the spark ignition engine. So here, what is spark ignition engine? So wait a minute, I have to activate this app. So it's not activating. So now it's okay. It's okay. So now this is the example of petrol engine or spark ignition engine. So it's not opening it. Or maybe I can open my Word file. So here, so it's not linked now. So we have to wait. So here, spark ignition engine. So the keyword here is there is an spark plug. You see, there is a spark plug here. You see, spark plug. So the fuel is ignited in this engine by means of the spark of the uh, spark plug. Spark plug. So spark plug. So that is SI combustion, SI engine or spark ignition. So there is an spark plug. So next, so Otto cycle is known as four-stroke spark ignition cycle. It was named after German engineer Nicholas Otto. So this engineer discovered the Otto cycle engine. So who invented? So developed and patented first four-stroke petrol engine. The four-stroke petrol engine works on the following cycle. So here, so suction stroke with the piston moving downwards. So here, so this is the piston. So piston moving downward. And the opening of intake valve or inlet valve. So the correct term is intake valve. So this one now is open. So valve creates suction of air fuel mixture. So there is so in the gasoline engine, when the piston is moving downward, the fuel and air is being sucked here. You see? So suck into the cylinder. So next stroke, compression stroke. So in compression stroke, with the closing of the inlet valve, it closes the above and the piston moves up, resulting in the compression of the air fuel mixture in the confined space. So now you can see the intake valve is closed and the piston is moving upward. So here, this is piston. So there is now a compression happen in these events. So that is compression stroke. So compression of air here together with the fuel mixture, because this is gasoline engine. So now followed by the spark. So this is a spark to the spark plug. So next stroke. So here there is a process, the combustion process. So at this stage the spark plug fires the sparks, which resulting instantaneous burning of petrol, causing an explosion. This causes the heat to release, which generates expanding forces known as power. So here, as you can see on this drawing, there is spark from the spark plug. So remember the keyword. If the question is SI engine, this belong to Otto cycle, which is using spark plug. So this is a spark plug. Next. So now, you can see here the combustion process. So, there is a compression of air and fuel here, mixture. Then followed by the spark plug. So, there is a combustion happen inside the cylinder. So now, as you can see, when the combustion happen, there is a expanding gases here. So in this area, here. So here, there is a expansion of gases. So when there is a expansion of gases inside the cylinder, the piston is pushed downward. So now the piston is pushed downward. So the piston is connected to the connecting rod, and the connecting rod is connected to the crankshaft. So the crankshaft is crank and continue turning. So that is the power stroke here. So now after the power stroke, there is so-called exhaust stroke. So now the exhaust valve is open. So as you can see here on the drawing, the exhaust valve is open. So the piston moving upward pushes the exhaust gases out. So here, so going to atmosphere. So that is the explanation of the SI engine. So the SI engine, remember, there is a spark plug. So the way this engine ignites by the use of the electric spark from the spark plug. So next, so it's quite the signal is slow. So here we will proceed with the compression ignition engine. So always loading. So this is compression ignition engine. So what is the difference between the SI engine and the compression ignition engine? So SI engine uses spark plug to ignite the fuel. So the mixture of air and fuel. But the compression ignition engine ignites the fuel by means of heat of compression. So I cannot write here with my we will try, but I can write. So I cannot write. So So just remember my explanation because I cannot write with my stylus. So basically, diesel engine principle and working cycle. Basically, there are two types of diesel engine. So 4-stroke and 2-stroke diesel engine. So the diesel cycle uses higher compression ratio. It was named after the German engineer Rudolf Diesel. So this engineer discovered the diesel engine. So he's German engineer. Was invented and developed first 4-stroke diesel engine. The 4-stroke of the diesel cycle are similar to the petrol or the Otto cycle. However, diesel cycle considerably differs by the way the fuel system supplies the diesel, the engine, and ignites it. So we will see. So here, this is example of diesel engine. So you cannot see a spark plug in this engine. So how this engine, the fuel ignited. So here, now this is a suction stroke or intake stroke. So the piston is moving downward. I will show you. So now the piston is moving downward. So the intake valve also open. So there is a flow of air here. So if this is turbocharged engine, this air is supplied by turbocharger. But if this is naturally aspirated engine, this air coming in the cylinder is being suctioned by the piston here. So when the piston going down here, there is a vacuum. So there is a suction of air inside the cylinder. So this is a suction stroke. Now, let us proceed to the compression stroke. So they are similar to the Otto cycle or the SI engine, spark ignition engine. But the difference here is the fuel system. So now compression stroke. With the closing of the inlet valve, the area above the piston gets closed. So here, you see, now the intake valve is closed. So the cylinder here is closed. So the piston moves up, resulting the compression of the air in a confined space, which is inside the cylinder, under higher compression ratio. So here, when the piston go up or moving upward, so I will put the arrow. There is a compression happen inside the cylinder. Compression of air here. So now you can see here there is a injector. So there is injector. So there is a spray of fuel. So now when the piston going upward, there's a compression. it will produces heat of compression. So, heat of compression ignites the fuel here inside the cylinder. Heat of compression. So, heat. So, it's very difficult to write with the mouse, no? So, just remember what I said. Heat of compression will ignite the air and fuel mixture here inside the cylinder. So that is pertaining to diesel engine or the diesel engine as example of CI combustion engine or compression ignition engine. So remember, SI ignition engine uses spark plug to ignite the air and fuel, and compression ignition engine, which is CI engine, ignites the fuel and air inside the cylinder by heat of compression. So that is the difference between the two between these two engines. So here let us go to the combustion process. Combustion process. As this stage, the injector sprays the diesel into the combustion chamber. The rise in temperature of the air, so heat of compression, caused by its compression results in instantaneous burning of diesel with an explosion. This causes the heat release, which generates expanding forces known as power. So now, as you can see here, there is a spray of fuel, which is this diesel fuel. So this is injector. So now, after this events, there is what we call the power stroke. So power stroke, this forces again pushes the piston downwards, resulting there is reciprocating motion. So here, you can see here, the combustion, this is combustion here, see? So it's not working now. I will activate. Now it's working. So here, this is combustion. So now the expanding gases here, because of the combustion, pushes the piston downward. So this piston has a connecting rod connected, and it is also connected to the crankshaft. So what happened? Crankshaft. So now this is connect. You see this here down here. This is the connecting rod connected to the crankshaft. So pushes the crankshaft will crank and continues turning due to the combustion also, or the power stroke of the other cylinder. So just like you are riding a bike, then you have to crank the bike to run. So here another stroke is exhaust stroke. So exhaust stroke, on their way up, the piston pushes the exhaust gases above them to the exhaust valve, which opens during the exhaust stroke. So as you can see here, the exhaust valve open. So now this is exhaust valve. So when the piston moving upward, this piston pushes the exhaust gas force here outside the exhaust pipe because the exhaust valve is open. So that is exhaust stroke. So it's quite the signal is slow. So we already discussed spark ignition engine and combustion ignition engine. Just remember that the spark ignition engine or the petrol engine or gasoline engine uses spark plug to ignite the fuel, whereas the combustion ignition engine or the CI engine ignites the fuel by means of heat of compression inside the cylinder, engine cylinder. So remember that. So another as classified by the this internal combustion engine. So there is also inline engine. So it's not it's quite difficult to open the link when the signal is very weak. So now it takes time. So this is inline type engine. So as you can see here, the arrangement of the cylinder is in the straight line. So keyword, the arrangement of the inline engine type, the arrangement of the cylinder is, as you can see here, vertically straight line, or there is also horizontally straight line engine. So but the common is vertical inline. So now inline engine is a type of engine design that is very basic and conventional. So we will directly here in this type of engine construction, the cylinders are placed in a straight line as shown in the diagram. So ito nakita natin, no? Straight line cylinder. So here, as the cylinders are a straight line, so we'll directly just a moment. So we'll directly so a straight inline engine refers to the engine which the cylinder arranged in a straight line. So this is also called a straight engine. So this one here. So straight engine. So remember the keyword inline engine, the cylinder arranged in a straight line arrangement. So let us proceed to B-type engine. So what is B-type engine? Its design, construction, and advantages. So the engine construction places the cylinder at the angle instead of in a straight line with each other. The angle between the cylinders varies from 60 to 90 degrees, so it depends upon the maker, no? So the angle between the cylinders form V shape, and that is why this engine is called V type engine. So remember the keyword, the angle between the cylinders form V shape. The cylinders form V shape is B type engine. B type engine. So here, this is a B type engine. So the cylinder arranged in V or form in V shape. This one, you see? So either 60 degrees angle or 90 degrees angle. So that is B type engine. So I will continue this recording later. So we'll discuss the gasoline engine, diesel engine, auto cycle, and diesel cycle later. So I will stop this recording. So we will continue with our discussion. So here we'll discuss that the spark ignition engine is an engine use gasoline or petrol as a fuel. Hence, this type of engine is called petrol engine, while combustion engine ignition engine use diesel as fuel. Hence, they are called diesel engines. So I'll open this link. So it's not opening yet. So this is the problem when we are directly connected to the internet. It depends on the signal. It is not opening right away. So we'll discuss this later, no? We'll open another window. So here we have, you see, in our syllabus, we have here gasoline or petrol engine. So what is petrol engine? So petrol engine, this is British English, or gasoline engine, this is American English. So an internal combustion engine with spark ignition designed to run on petrol engine. So petrol engine, there is a spark plug, or this engine is called spark ignition engine. So that is petrol engine. So they are the same gasoline engine and petrol engine, but in terms of the petrol engine is in British English, but gasoline engine is American English, but they are the same. So gasoline engine uses gasoline or petrol. So here another meaning and Encyclopedia Britannica. Gasoline engine, any of class of internal combustion engine that generate power by burning a volatile liquid fuel, such as gasoline or a gasoline mixture, or what we call the petrol. So we'll see this one. So it's not, I will try to uninstall one app. Yes, this is I think it's making happen. Gasoline engine, any of class internal combustion engine that generate power by burning a volatile liquid fuel, gasoline or gasoline mixture such as ethanol. So with ignition initiated by an electric spark. So remember the keyword electric spark in a gasoline engine or SI engine. So we'll go to the diesel engine. quite hard to open this this internet. So here the diesel engine, namely named after Rudolf Diesel. So this is a German engineer, Rudolf Diesel. So this diesel engine is taken from his name, Rudolf Diesel. So it's an internal combustion engine in which ignition of the fuel is caused by the elevated temperature of the air in the cylinder due to the mechanical compression, adiabatic compression. Thus, the diesel engine is so-called compression ignition engine, or the CI engine. So, the difference between the petrol engine or gasoline engine or SI engine between the CI engine, which is diesel engine, is by way of igniting the fuel. So gasoline engine fuel is ignited by means of electric spark, by means of spark plug, whereas the diesel engine, the fuel is ignited by means of heat of compression. So later I will show you what will happen in this the working process of the petrol engine and the diesel engine. So yes, opening this one. Try first to uninstall one app. Maybe the reason of lagging my computer. So here we will discuss the difference between up into this computer. So we'll continue. So we'll discuss the difference of Otto cycle and diesel cycle. So here we have the Otto cycle and the diesel cycle. So now the difference between Otto cycle and diesel cycle. So significant it is to discover the answer of this, as many of us still unaware of what these terms mean. So many of you, auto cycle is used by petrol ignition, whereas diesel engine uses the diesel cycle. The main difference that separates these two cycles is the way they supply heat to the engine to begin ignition. So another noteworthy difference is that the auto cycle heat occurs at constant volume, whereas the diesel cycle works on a constant pressure. This could be the main difference between auto cycle and diesel cycle. Besides, there are other differences as well, which we are going to explain here. So now, difference between auto cycle and diesel cycle. While the main difference is the way the cycle supplies heat to engine, we can have certain other differences here which are worth knowing for us. So the first difference, auto cycle and diesel cycle, lead us back to the difference when it was proposed. The idea of auto cycle was given by Nicholas Otto back then in 1876, while the other one, the diesel cycle, was proposed by Dr. Rodolph Diesel, who introduced it to the world then in 1897. So the idea was proposed by the two different people in different years, which differentiated these two cycles at this first point. So now we have here the PV diagram, the pressure volume diagram. So first we have to discuss the auto cycle. So here the auto cycle. So what happened? So it's not yet opening. So I will open this up. So here we start first the auto cycle. So this auto cycle. See. So here from P1, this one P1 to V1. So P1 and V1, P1 and V1. Here, this when we applying to the engine, here is intake. So intake stroke. So I cannot try. It's very difficult to. So here, from here to there is intake stroke, and from P1, so here from P1 to P2, so here is P2 for pressure 2, and B1 to B2, so here is B2, this area, this one is B2, and this one is B1. So from 1 to 2, the stroke here is compression. So this is in the Otto cycle. So here from 2 to 3, which is P2 and P3. So here P2, here is P3. So this is P3 and this is P2. So now here is ignition. So ignition followed by the combustion. So remember this red line, this is ignition followed by combustion. So in thermodynamics, this is heat added, and here is heat rejected. So here in the P3 to P4 or pressure 3 to pressure 4, or this is what we call the V3, V2 and V1. So P3 to P4 or pressure 4. So here is the isentropic process, which is here is power. So here the isentropic process here is compression. So here is power 3 to 4, and 4 to 1 is exhaust. So here 4 back to 1 is exhaust, or in thermodynamics that is heat rejected. And here 2 to 3 is heat added in thermodynamics. So our engine is applied with thermodynamics principle. So that is Otto cycle. Now later on, after discussing the strokes, this engine, we will differentiate the Otto cycle and diesel cycle. So now here is the diesel cycle. So in diesel cycle, as you can see on the PPD diagram, they are already different. So here, this is P1 and this is B1. So here B1. So P1 start here. So B1. So now here is also intake stroke. So in diesel cycle engine, this one also is intake stroke. So from P1 to B1, or P1 and B1 is intake stroke. So here is compression stroke. So compression stroke. So here is, you can see the red line, ignition. So here is ignition. P1, P2 and P3. So this is P3. So here is power. So they are the same in the Otto cycle, but there is a difference. Here is exhaust. So this is exhaust, 4 to 1. Now, here, as you can notice here, so the pressure here during ignition is constant. You see, it's constant. Pressure 2 and pressure 3 has the same pressure during ignition, while in the Otto cycle, pressure 2 and pressure 3 has different pressure. So from lower pressure to higher pressure, the Otto cycle start to ignite. Whereas here in the diesel cycle, the ignition takes place with a constant pressure. So pressure 2 and pressure 3 is constant. You see, this is the same. This level is the same pressure. So in other words, the Otto cycle, the difference of the Otto cycle and diesel cycle here in our PV diagram, the Otto cycle works at constant volume. So you see, from B1 to B2 or volume 1 and volume 2 here, the pressure is the same, you see? Here, the volume, sorry. So B1 and B2 working in constant volume. Whereas, so you say it start ignition here at pressure 2, but the volume is the same. You see? You see this the label of the PV diagram. So the volume is the same. Whereas in diesel cycle, so this is Otto cycle, the volume is the same during ignition, but the pressure is from lower to high pressure. So here in the diesel cycle, here the pressure is constant, you see? So P2 and P3 or pressure 2 and pressure 3 is constant during ignition. So that is the difference between these two cycles, diesel cycle and Otto cycle. So remember the keyword. They differ, the Otto cycle and diesel cycle. During the ignition, the Otto cycle is the volume is constant, the pressure is variable, and the diesel cycle, the pressure is constant. So these are the difference. During the ignition, the diesel cycle, the pressure is constant during the ignition, but the Otto cycle, the volume is constant during ignition. So that is the difference between the Otto cycle versus diesel cycle. So this is additional information. So we know already the difference of the Otto cycle and diesel cycle. So for more information, you have to follow this link. This one. Just follow this link for information. So now, let us proceed to the steam engine and Stirling engine. So these are two types of external combustion engine. So first, we will open the link of external combustion engine. So we will open this one. So my computer now is lagging. So now, so this is the the old invention. So I will search another window. What happened to my computer? It's not responding. It's not. I'll open again. PPD. So just be patient. My computer is lagging now. Probably there is malware again. So I already scanned this computer, but it's so external combustion engine. So we will search. External combustion engine. So external combustion engine, or ECE or EC, is a heat engine where a working fluid contained internally is heated by combustion in an external source to the engine wall or heat exchanger. The fluid then, by expanding and acting on the mechanism of the engine, produces motion and usable work. So, in other words, external combustion engine, the fuel is not born inside the engine. So it is born outside the engine, which is called boiler. So if the engine is external, it requires boiler to produce steam. To convert water into steam, and the steam is used to drive the impeller of the internal combustion engine. One example there is steam turbine. So I will show you what is steam turbine. So steam turbine. So this is an example of steam turbine. So a steam turbine, so this is an example of steam engine or external combustion engine. So a steam turbine is a device that extracts thermal energy or pressurized steam and uses it to do mechanical work. So on a rotating output shaft. So here, I will show you this picture. So steam turbine. So this is example of external combustion engine, steam turbine. So to give you an idea, we'll play this. There's a video. So how this external combustion engine works. So this is steam turbine. So we have another also external combustion engine, which is Stirling engine. So I will play this video. So just be patient. The signal is not good. So this is the explanation of steam turbine. So the example of we have here external combustion engine. So example of steam engine. So example of steam engine is steam turbine. The video that we watched a while ago. So this is an example of external combustion engine wherein the fuel is burned in the boiler and the boiler is producing steam to drive the steam engine. So one example of steam engine is steam turbine. So now we have to look at it the Stirling engine also. So Stirling engine. So here, so I will click this link. So this is example of Stirling engine. So I think it's good to watch the video. So first we will define what is Stirling engine. So Stirling engine is a heat engine that is operated by a cyclic compression and expansion of air or other gas as a working fluid. So at different temperatures, resulting in a net conversion of heat energy to mechanical work. So this is Stirling engine. So in this principle, see. So in the definition, it says that this engine is working by the principle of different temperature. So by way of compression, cyclic compression and expansion. So you see, this blue color here is cold, and here the red color is hot. So in the definition, it is a cyclic compression and expansion at different temperature. So you see, here the gas is hot. So if the gas is hot, there is an increase of pressure. So the increase of pressure here pushes the piston towards there, forward. See? And here also is cold gas. It's a cold gas. So between these two pistons, there is what we call the contraction happen. So when the piston moves towards here, the piston rod moves and turn this crankshaft, and since there is a contraction of different gases here between cold and gas. This one also pushes back the piston here. So pushes forward here and continue turn the crankshaft. So between these two temperatures here of the different gases, rotate the crankshaft by the cyclic process called the compression and the expansion. So we look at the video here of Stirling engine. So just a minute. So Stirling engine. So these are Stirling engine. So we will look at the video. So the first experiment, the experiment how this engine invented. So this experiment, we will play this video. Stirling engine. So this is hot water, and you see how the Stirling engine works.
I recently acquired this little machine. Its motion is intriguing. Apparently it is deriving energy from a cup of hot water. This is a Stirling heat engine. Like an internal combustion engine, this machine does have a piston, cylinder, and crankshaft, and it does rely on gas pressure to create motion. But unlike a combustion engine, there is no explosion, no intake or exhaust valves. In fact, the gas involved, which is air, is sealed inside the machine. It stays there. Somehow this reservoir of air is used to cycle energy, creating mechanical motion. The energy being cycled here is heat energy. Exploiting heat energy requires a temperature differential. That is, hot and cold areas in the machine. In this engine, this bottom metal plate is hot, while the upper metal plate, this one, is cool. Note that the cylinder joining the metal plates is plastic, a material that will provide some thermal insulation between the plates. Inside this cylinder is a large loose-fitting piston. Interestingly, this piston does not drive the machine. Named the displacer, it plays a role in heat transfer. We'll return to it in a minute. This small cylinder with a tight-fitting piston is the power cylinder. It is the mechanism producing the force to move the machine. Here's how this works. The bottom metal plate is hot. The upper plate is cool. I've rotated the flywheel so that the displacer is at the top. This means the large volume of air below the displacer is exposed to the hot plate. This gas is picking up energy and expanding. The resulting increase in pressure exerts force throughout the closed system, including on the power piston. This force pushes the piston up, turning the crank and rotating the flywheel. The displacer is also connected to the flywheel by a crank. This crank now lowers the displacer, exposing the air to the upper cold plate. The air loop.
So remember, there is a contraction of the different temperature here. This is hot and this is cold. So that's why the force here, the pressure pulls the piston upward, and the cold gas contract or oppose here. So this also pushes back. So the piston moving in reciprocating motion continuously.
Loses energy. Its pressure drops and the momentum of the rotating flywheel moves the power piston back to the bottom and moves the displacer up, once again exposing the air to the hot plate. The air expands and the increasing pressure starts the power piston on another power stroke. The flywheel plays an important role. Its momentum maintains motion when the gas is contracting, cycling the machine into the next power stroke. This cycle repeats as long as there is a temperature differential between the upper and lower plates. Apparently, the difference in temperature between your hand and the ambient air can be enough of a differential. I was unable to get the machine to start using the temperature of my hand, but once started with another heat source, the heat from my hand was enough to sustain motion for a few minutes, particularly if I moved outside. The air temperature is -7 degrees Celsius here this morning, significantly lower than the temperature of my hand. The invention of the Stirling heat engine is attributed to 19th century Scottish inventor Robert Stirling. The science behind this machine can be attributed to the genius of earlier researchers, people like 17th century scientist Robert Boyle and Blaise Pascal. Like so many other inventions, this elegant little machine represents the creative potential and genius of humankind. Visit our website at hylaroad.com/Stirling for more information about Stirling engines, including links to suppliers of Stirling engine kits. For more science and technology videos, visit our YouTube channel, Science Online.
So this is the explanation of the Stirling engine. So we already discussed the as a recap. We already discussed the history of engine types of the internal combustion engine. We already discussed the difference between internal combustion engine and external combustion engine, as well as we already discussed the different classification of internal combustion engine, how they are classified, and we already discussed the spark ignition engine, which is petrol or gasoline engine. We already discussed also the combustion ignition engine, CI engine, which is the diesel. One example is diesel engine. And we already discussed what is gasoline or petrol engine and what is diesel engine, as well as the Otto cycle and the diesel cycle. We already discussed the steam engines, Stirling engines, which are the two types of external combustion engine. So you have to watch this video